at the end. When talking of terminals, I also consider graphical terminals here. So this isn't solely about text terminals. And so if I talk about text terminals, I will explicitly say terminal emulator or text terminal. Okay, what is config VT? This is the kernel configuration option which controls the VT layer. This isn't about TTYs. We will always use TTYs for terminal emulation, but the VT layer controls device access. That is, we have several VTs and only one is active, and only the process which is on the active VT can access graphic, or should access graphic devices and input devices. It does also provide a terminal emulation layer, which is a VT102 emulator, which is quite old and not that often used today. And based on this, we also have VGAcon and FBcon, which isn't part of config VT, but which depends on it, so it doesn't work without it. What do we use it today for? It is basically a session dispatcher, so we can use multiple X servers, for instance. We can switch between them, we can implement fast user switching. It is also a lightweight UI, so if you don't have an X server, or you don't have any hardware with DRM drivers or DDX, you need, but still you need an UI, then you can use a Linux console. It's also used as an emergency console, mostly by developers. If your X server crashes, you want to recover it, or you want to repair it, and then you often use the Linux console. Or for Western development, Wayland development. It's also used as a kernel log in situations where there is no working user space, for boot and shutdown logs, for oops and panic screens. This is only for debugging, of course, because you use graphic reader screens, you don't use this. And last but not least, it's also used for backwards compatibility for all programs which require VTs, which currently includes the X server. So if we replace it, we need to provide a replacement which does all that, of course. Digital equipment produced the video terminals 102 to 520 in the late 80s, I think. And these are basically standards how we do terminal emulation today. And Xterm is the de facto standard for Linux. And the Linux console does only VT102, which is quite limited, and I think everyone who has ever worked with it and tried to do some more advanced stuff has noted that it does things differently, and there are many hacks to get around it. It also has lots of private extensions to load other fonts or keyboard configurations, which are not used by any other system, but only by the Linux console. So what problems do we have with the Linux console? If you think of it, it's basically a user interface in kernel space. It has been there since the first release of Linux, and no one ever took the steps to remove it. But today we would never introduce a user interface as kernel code. So the question is, why do we still have it? It's poorly maintained. I think Greg Hartman still maintains it as part of the TTY layer, but there hasn't been any major modifications in the last years. It has bad keyboard handling, doesn't use XKB or any XKB compatibility. It has a bad font renderer. We can only display 512 different clips. It's missing multi-head support, no proper mode setting support. It's not multi-seat capable, so if you have multiple seats on your system, you have VTs only on the first seat. All other seats, well, don't interfere there, but they also don't have the possibility to switch between multiple applications. Hot plugging is limited. This is mainly for the FBDIF layer. Input device hot plugging does work, of course. And of course it's limited to VT102 emulation. It also has blinking cursors, which, well, it's no problem per se, but like 90% of all bugs of the VT layer were related to blinking cursors. because this part, the timer interrupts. What solutions do we have? Of course, we can move it to user space. I think this is the only good possibility, because then we can do XKB, we can use Pango to render fonts, we can use OpenGL if we want, and this is of course all limited to user space. We can't do this in the kernel. Reasons to keep config.vg is the oops or panic screen. We can't do this in user space because we cannot schedule any user process if there is a panic. And some people also mentioned that they want an emergency console which always works, but this is actually not valid because you cannot use a console if you have no working user space. You need a shell, bash, whatever. So this is actually no reason to keep config.vg. If you have no working user space, there's no reason to get a console. And for the oops and panic screen, I have a replacement which has already been posted to FOSDEM mailing list, and I will talk later about it. So I think I have found no reason to keep it in the kernel. So I've written KMSCon. It's about 1 year old now, and I started it in November 2011 and improved it during Google Summer of Code. It's basically a terminal emulator in user space, like any other terminal emulator, but without any X dependencies or any other rendering library dependencies. It can do a lot more. I will talk about that later, but first I want to concentrate on the terminal emulation part. It's split into 3 parts: a library called uterm, which is written as part of KMSCon but independent of it, and it allows to write terminals for Linux machines in user space. It is not related to any terminal emulation, but it provides, for instance, a layer to for hot plugging. It notifies an application about new input devices, notifies about new graphics devices, and if they have gone away, and it will do XKB keyboard handling for the application. It also provides a graphics display API to perform mode setting, and more. It's useful for all kinds of projects. You can use it, for instance, as backend for Western to implement to replace DRM backend if you want. And some other projects have already asked me whether I could stabilize the API. Another part is TSM, which is a terminal emulator now, which is similar to BTE from the GNOME project, but without any GTK dependency, so you can use it in any other project if you're not on X. I won't talk about that anymore because I think there's not much interest here. And of course there's the main KMSCon application. What features do we have? KMSCon is highly modular, so it only depends on XKB common to do keyboard handling. It depends on UDEF, of course, to get device hot plugging, and it depends on Pixman for S2D renderer. All of these libraries have only glibc as dependency, so you can even link it statically to get an emergency console for init.rd or any other situation, which is important because if you want to replace a Linux console, you need a binary that works under all conditions. libdrm is optional. You can use FBDIF as backend, but I would recommend using DRM. Everything else is optional. You can load it during runtime, so this is perfect for package managers, which can install a basic KMSCon binary and all the modules separately. It does seed device hot plugging, so if you start KMSCon, you can actually just create a new seed on your machine and it will pop up there. You can plug in a monitor or remove it. You can plug in graphic cards and remove them. I tested this with some PCI cards. The problem is that removing them crashes nearly all the kernel drivers, so you can't test that really. But with the UDL driver, the display link driver, you can plug in as many graphics cards as you want. You can configure it per seed or per device. It's up to you. And it has an integrated session manager. I will talk about this later more, if it's about VTs, but KMSCon doesn't start a terminal emulator by default, but it starts a session manager. And you can start the terminal session in this session manager and switch between different sessions. Of course, the emulator is FOSDEM compatible, so you can run all your normal terminal programs on it. It provides the same keyboard configuration as X via XKE. And of course, fully internationalized. You get all kinds of glyphs. You can draw any language you want, and you can even get hardware accelerated rendering. But this is of course limited to, well, mostly just copying textures, so it doesn't accelerate that much. I can give a short demo here. This is just a file with several Unicode characters. You can see that it does, if a special font does not contain glyphs, it just replaces them. You can, for instance, see several Unicode characters which are not available in the normal fonts which are configured here. I think it's bit Primavera. You can do multi-line integrals. Everything you expect from a normal terminal emulator you will now get on the Linux console. Yes. And okay. You can already use KMSCon to replace AGETI. If you use systemd, of course, this is just an example. You can use it without systemd, but you can simply use systemctl start KMSCon VT and then followed by the TTY where you want to start it, or by the VT. And you can even replace the standard auto VT service which is used by systemd login D to start the normal VT AGETI process. It even starts AGETI if it fails, so you get it back on your normal console. Yeah, this is all about KMSCon as a terminal emulator I wanted to talk about. If there are any questions, otherwise, yeah.
Yes, concerning internationalization, what about input handling, input method?
Yeah. KMSCon uses XKB Common, which is a library which was written by many X developers that work on the XKB layer, X keyboard layer, and it provides the same keyboard handling, and it gets all the input events from the kernel via input devices, and well, it puts that into XKB Common, and you can load different keyboard layouts, the normal RM LVO options like layout and model.
Yeah, but more complex for Asian languages. I mean, I myself type Japanese quite often. I would like to have an input method where I can, that does translation.
Okay, yeah. Okay, you can do that, of course. I haven't implemented it yet because, well, it's in user space. You can do whatever you want with it. For instance, if you want an on-screen keyboard or something like that, if you mean, or if other input methods which help you can be implemented via modules in KMSCon, that's no problem. You get notified about any key that is pressed. You can create virtual keyboards, do all that. I've mostly implemented all this stuff that was unclear whether it works, but of course there are many features which you can which I'm still working on, but there's no restriction in what you can do regarding input features. But you can do basically anything. Yes.
So do you have any interest from OSVs to integrate this from distros?
It's already in Arch Linux. You can install there, and I'm talking with the Fedora people for Fedora 20, not 19, and well, I haven't looked for Debian or Ubuntu yet, but will definitely.
What is your you started by stating there were font problems in the current system. What is your font rendering stack when in your preferred configuration.
Sorry.
So when you presented dependencies,
Yeah.
you put only libpixmap as a mandatory dependency.
Yes.
What is the configuration you expect the distributions to use to render fonts?
Distributions can actually use the very basic KMSCon as a binary and provide that. And the different modules like the font renderers and other rendering backends can be installed via different packages. I expect them to use, well, Pango should be used because you want more nice fonts. Other than, I have a list of modules which are recommended, and a list of modules which should, well, can be used, like hardware accelerated rendering should probably not be used because, for instance, on my machine it's horribly slow. But yeah, I put a lot of effort into moving all the different backends into modules that a user can just install separately, so you don't have to maintain different KMS conversions in your distribution. But well, I recommend using the standard binary, of course, and then yeah, I have a list of a few modules, but yeah. Otherwise, you can always ask if some modules are useful or not. But I think it's pretty obvious in most cases. Okay, then I will continue with virtual terminals. I want to give a short overview of what they actually are, and then what the problems is with virtual terminals, and then how we can replace them. Today, virtual terminals are used to control access to input and graphics devices. I try to compare to other devices like audio devices or video for Linux 2 devices, but it requires other access restrictions. And because audio, for instance, can serialize access and can mix it. Video for Linux just allows one application, as far as I know, to use a device, and we don't want that for input and graphics devices. The kernel layer itself provides different mechanisms. Input devices provide grabs. These shouldn't be used because if you grab a device, no other process can use the device, not even the kernel, not even sysRQ can use it. So that doesn't really help. And DRM devices provide DRM master logic. I already heard about that. It's restricted to root only if you want multiple applications. Otherwise, you can just open it. The first device that opens the DRM device automatically gets DRM master, even if it is not root. So, yeah. FBDEF doesn't provide any mechanism at all. If two processes use an FBDEF device simultaneously, just screw up. You access virtual terminals via DevTTY, of course, and only one VT is active at a time. Historically, there was text mode. That is, the VT provides just a TTY, just as a normal TTY. You read to get input events, you write to write the text, which will then be displayed by the kernel, and you use, or you control it via IO. In graphics mode, you ignore all that. You just set up your device and use it for synchronization, so you get events when you get activated and deactivated, and otherwise you ignore it. So you can remove a lot of the VT layer and still get the same, still get everything that you need. Problems with VTs. As an ugly API, it is signal-based. That is, you must set up your signal handlers to receive a signal if you have activated and deactivated. That really messes up if you want multiple VTs to be controlled in a single process, because you only have SIG user 1 and SIG user 2. You can do it, but it gets really messy. It's unrelated to input or graphics devices, so there's no chance to tell a VT to only use a limited set of input devices via the VT layer, and it is unmaintained with mentioned, well, it is maintained, but nobody really wants to improve it or work on it or even fix bugs. Another problem is if you have a dead VT, that is, for instance, your X server, which is going to be active. If it deadlocks, you cannot switch away from it. It doesn't really help to use sysRQ or other keys, because the process is still alive, but it cannot release the VT, so you cannot control switch away. There's no chance to find the number of the VT that you opened. You can, of course, if you open dev TTY7, you know it's TTY7. But if you open any symlink to it or something else, there's no way to find out which VT you just opened. There's no VT who am I. KMSCon uses FStat to find the minor number, but that isn't really reliable and not part of the ABI. But well, the kernel doesn't break existing user space applications, so now it is part of the ABI. But yeah. Another problem is it is not multi-seed aware, so VTs are only attached to seed 0 or the default seed. On other seeds, well, you have simply no VTs. This is also not easy to fix, because if you add VTs for other seeds, you also have to have a mechanism to tell the kernel which devices to attach to a seed, because you want only some devices to be on a different seed, not a default seed. So it's pretty obvious that we want a replacement for that. And before we can think of a replacement, I want to describe what we actually want from this replacement. So on a normal system today, we want to run compositors. We want to run an X server, we want to run Western or DirectFB, which provide a user interface for client applications which can then display their content. We want an emergency console, which is mainly for developers which will crash the X server or crash Western and want to recover that without reboot. We want to support standalone applications like XBMC, for example, and of course we want to support legacy applications which still use VTs, and any combination of that. So we want to switch between all these things.